Hello everyone. SEM-I లీనియర్ ఆల్జీబ్రాలో యూనిట్ 2కి సంబంధించి ఆల్మోస్ట్ we completed all the problems, means all the theorems or problems. We have mainly one theorem, that is the Rank-Nullity theorem. Rank-Nullity theorem, or generally we call rank theorem. Okay, rank theorem. Based on this rank theorem we have some problems. Okay, so state and true rank theorem also important, and problems and rank theorem also very important. So in this video today we will discuss about rank theorem. Okay, how we will show and how we have to prove this rank theorem, now we will see. So before going to start today's class, మన ఛానల్కి కనుక ఎవరైనా ఫస్ట్ టైం వచ్చిన వాళ్ళు ఉన్నట్లయితే సబ్స్క్రైబ్ చేసుకోవడం మాత్రం మర్చిపోకండి. వీడియోని ఎండ్ వరకు చూడండి. వీడియో కొంచెం లెంతీ రావచ్చు, బట్ ఐ విల్ ఎక్స్ప్లెయిన్ ఈచ్ అండ్ ఎవ్రీ టర్మ్ అండ్ ఈచ్ అండ్ ఎవ్రీ పార్ట్ ఆఫ్ దిస్ థీరమ్. సీ ది వీడియో టిల్ ది ఎండ్. ఓకే, సో బిఫోర్ గోయింగ్ టు statement of Rank-Nullity theorem, you need to know some definitions. And two small theorems. So if you know these definitions and the two small theorems, then only you need to understand, you will get clarity on Rank-Nullity theorem. Okay, so what are the definitions, what are the theorems means? First definition, null space of T. Okay, you need to know what is null space of T. Second thing, range of T, means range space of T. This also you need to know what is range space of T. Then after you need to know two theorems. One is this null space of T is a subspace of domain. It is a subspace of domain, and range is a subspace of codomain. Range is a subspace of codomain. So this will ask for short questions also. So these two theorems, statements, and this null space and range space, these four concepts are very important for our theorem proof, that is Rank-Nullity theorem. So we will start our null space of T. So what is null space of T means, let T be a linear transformation from the vector V into W, where V and W are vector spaces over the same field F. అంటే ఒక ఫీల్డ్ పైన V అండ్ W అనే రెండు వెక్టార్స్ని తీసుకుంటున్నాం. ఈ రెండు వెక్టార్స్ అనేవి లీనియర్ ట్రాన్స్ఫర్మేషన్ అయితే, ఓకే, సో let T be a linear transformation from V to W. Here V and W are two vector spaces over the same field F. Then how we will define this null space means, null space of T or kernel of T. So ఈ వర్డ్ మీరు విని ఉంటారు, kernel of T we will call kernel in algebra, that is in 4th SEM algebra. Now we will call this kernel only null space in లీనియర్ ఆల్జీబ్రా. ఓకే, ఆల్జీబ్రాలో మనం కెర్నల్ అని దేన్ని అయితే యూజ్ చేసామో ఆ కెర్నల్ కాన్సెప్టే లీనియర్ ఆల్జీబ్రాలో నల్ స్పేస్ అనమాట. బోత్ ఆర్ సేమ్. ఓకే, సో నల్ స్పేస్ ఆఫ్ టీ కెన్ బి రిటన్ యాజ్ ఎన్ ఆఫ్ టీ. ఇట్ ఈస్ డినోటెడ్ విత్ ఎన్ ఆఫ్ టీ. ఎన్ ఆఫ్ టీ ఈజ్ ఈక్వల్ టు ఆల్ఫా బిలాంగ్స్ టు వి such that T of alpha is equal to 0. This is the definition of null space of T. This you should know. Okay, మీకు తెలియాల్సింది ఏంటంటే n of T is equal to alpha belongs to V అయితే T of alpha is equal to 0 అవుతుంది. How it is means, here domain and here codomain. Okay, so here linear transformation. If we take any element in this alpha, beta or anything, if you do linear transformation, if you apply linear transformation to these elements, then you will get what? T of alpha, then T of beta. Here it will be T of alpha and T of beta. This both should be 0. Not only these two, if you take any value in the domain, the answer of codomain should be 0. Means every element of domain should be mapping with 0, then this set of this all codomain elements only we call null space. Okay, null space is nothing but set of elements in codomain. What elements are mapping with only 0, then that set is called null space of T. Okay, now we have to prove this null space of T is a subspace of domain, that is V. So V to W, we are taking here V to W mapping, no? So we have to show this N of T is a subspace of V. Let us see. Prove that N of T is a subspace of V. Okay, so let us take any element in the domain, means 0. Let us take 0 is a element in V, then null space of T means every element should be mapped with 0, that is T of 0 is equal to 0. So 0 belongs to null space of T. Okay, T of 0 is equal to 0 means what? This 0 will belongs to null space of T, and hence here in null space there will be one element, that is 0, means it should not be empty. Here it is one element 0, so here it should not be empty. Therefore N of T is not equal to 5. Not equal to 5 means N of T is not a empty set, it has a element that is 0. So let us take two elements. Okay, now we have to show linear subspace of V, means we have a condition. What is that? Means if T of C alpha plus beta is equal to 0, then the C alpha plus beta belongs to N of T. Okay, T of alpha is equal to 0 means what? This will belongs to N of T. So this is the condition for subspace of T. Okay, this is the condition for subspace of T. If it is satisfying T of C alpha plus beta is equal to 0, then C alpha plus beta will belongs to N of T, then N of T will become subspace of V. Okay, so let us take, for this we have to take two elements, alpha comma beta belongs to N of T. Alpha beta N of T lo unte, C of alpha plus beta also N of T lo unnatlaite, then we can say N of T is a subspace of V. So alpha beta belongs to N of T means T of alpha belongs is equal to 0. Why? Because N of T is nothing but null space of T. Again T of beta also is equal to 0. Why? Because N of T is a subspace of, N of T is a null space of T. Right. Then we have to show T of C alpha plus beta is equal to 0. T of C alpha plus beta can be written as C into T of alpha plus T of beta. Why? Because T is a linear transformation. So here linear transformation means T of A alpha plus B beta can be written as A into T of alpha plus B into T of beta. We have a condition for linear transformation. One more, T of C alpha is equal to C into T of alpha. These two are the conditions of linear transformation. Here T is a linear transformation, that's why we are writing here directly C into T of alpha plus T of beta. We know here T of alpha is 0, T of beta is 0. C into 0 plus 0 is 0. 0 into anything 0, so that total it will be 0. So T of C alpha plus beta became 0. So T of C alpha plus beta 0 means here T of alpha is 0 means alpha, where it is alpha? Alpha in N of T. Same like that, T of C alpha plus beta is equal to 0 is nothing but C alpha plus beta belongs to N of T. C alpha plus beta belongs to N of T means this is a condition for subspace. Therefore N of T is a subspace of domain V. Right? Why? Because here C belongs to F. C is a any element in F. Okay. Therefore N of T is a subspace of V. Why? Because this N of T is a subspace of V. Why? Because here it's satisfying the condition C alpha plus beta belongs to N of T. I hope all you clear how we proved this. Okay. Now see the one note, that is if V is a finite dimensional, then dimension of null space of T is called nullity of T. Okay. Here this is V, this is W. If V is a finite dimensional means here finite number of elements 1, 2, 3, then the dimension of null space of T will T is what? This 3 only, nullity of T, that only we call nullity of T. Dimension of null space of T, null space of this all mapping to 0, then dimension of null space of T will become 3, that only we call nullity of T. Okay, okay, so dimension of null space of T only we call nullity of T. Nullity of T is nothing but a particular number. Null space is nothing but a set of elements. Okay, these both are different. Null space is nothing but set of elements, those are mapping to 0. And nullity means, dimension means how many number of elements are present in the null space only we call nullity of T. Okay, these both are different. Okay, then now we need to know, you need to know range space of T. What is range space of T? So let V and W be two vector spaces over the same field F. T be a linear transformation, then the range space of T is denoted by RT. RT is equal to T of alpha for all alpha belongs to V. Means same set, here V and here W. Here it is T is a linear transformation. If you take any element in this, then the elements will be T of alpha in codomain. If here it is beta, here it is T of beta. If this all the terms in codomain is 0, then that is null space. Okay, if how many elements are mapping like this, the set of this all the elements, the range of this codomain only we call range space of T, right? Range of this codomain is called range space of T. This can be denoted with RT. That is N of T. This is R of T. R of T or RT, anything. Okay. Range space of T means range space of T is nothing but how many elements are present in a range of a codomain. Range of a codomain. Codomain is different, range is different. No. For example, 1, 2, 3, 4. Here 1 A, B, C, D. Okay. Just to take A, B, C. Here A is mapping to 1, B is mapping to 2, C is mapping to 3. Then the range space will be 1, 2, 3 only, not 4. Why? Because this range of codomain only range space of T. Okay, this 3 only range of a codomain. So this 3 only will become range space of T, not this element. Why? Because this is element in codomain, not in range. Range is nothing but what elements are mapping with domain. Okay, I hope all you clear up to here. Okay, now you need to know one note point here, that is rank of T. Okay, sorry, here I will show. So rank of T here not there, no. So rank of T is nothing but dimension of range space. Okay, dimension of range space means here domain, here codomain I said no, here 1, 2, 3, 4. These 3 are mapping. Okay, rank, what is rank means the number of elements present in the range space. Here how many elements are present? 3 elements are present. So rank of T will be 3. Okay, so this is not in range, so this not will be rank of this transformation T. Okay, this is rank. So range space is nothing but 1, 2, 3 is range space. Rank is nothing but dimension, how many elements are present in range, that only rank. Okay, rank is different, range is different. Okay, now we have to show this range space is subspace of W. This is V and this is W. No, I said now only 1, 2, 3, 4. Okay, so this range space is a subspace of this W. Range is a subspace of W. అంటే W అనేది లార్జెస్ట్ సెట్ అయితే, లార్జెస్ట్ స్పేస్ అయితే దానికి సబ్స్పేసే ఈ రేంజ్ స్పేస్ అని నౌ వి హావ్ టు షో. ఓకే, రేంజ్ స్పేస్ ఆఫ్ T, RT is subspace of W. We have to show RT is subspace of W. So if you want to show any set is subspace of any superior set, before that you need to show that is an empty set. Why? Because subspace is a definition only. We have every empty set definition starting only we will say every non-empty set. Okay, in the definition itself every non-empty set. So we have to show before this Rt is non-empty set. For that reason here we have to take T of 0. T of 0 value is 0. So 0 belongs to R of T. Then Rt is not equal to 5. Therefore Rt is non-empty set. Just we will take this directly. T of 0 is equal to 0 means T of x is equal to x, for example. If you take here 0, then you will get 0. So 0 is belongs to R of T, then 0 is not a empty set. Now we have to show it is a subspace of W, means C of alpha 1 plus alpha 2 is equal to something, C of beta 1 plus beta 2 is belongs to R of T, we have to show. So for that reason we have to take two elements in domain and two elements in codomain, beta 1, beta 2. Here T is a mapping, means T of alpha 1 is equal to beta 1, T of alpha 2 is equal to beta 2. Now we have to take. Then beta 1, beta 2 belongs to R of T, codomain R of T in range. Then there exists alpha 1, alpha 2 belongs to domain V. Then T of alpha 1 is equal to T of alpha 1 equal to beta 1, T of alpha 2 is equal to beta 2. Now we have to show C of C beta 1 plus beta 2 is equal to, okay, C beta 1 plus beta 2, T of C beta 1 plus beta 2 is equal to, here C I did not wrote, just to see this, C of C beta 1 plus C beta 2 is equal to, sorry, C beta 1 plus beta 2 is equal to, in place of beta 1 substitute T of alpha 1, in place of beta 2 substitute T of alpha 2. Now T is a linear transformation, we can write like this, T of C alpha 1 plus alpha 2. T of C alpha 1 plus C alpha 2. So before theorem we chosen this, okay, ఆ థీరంలో మనం ఇట్లా రివర్స్ చేసుకుంటూ వచ్చాం, ఇక్కడ రివర్స్ చేసినాం అనమాట, అంతే, దెర్ ఈజ్ నో డిఫరెన్స్. ఓకే, నో ప్రాబ్లం. C into T of alpha 1 plus T of alpha 2 can be written as T of C alpha 1 plus alpha 2. So observe here, T of alpha 1 is equal to beta 1 means alpha 1 in V. Same like that, T of C alpha 1 plus alpha 2 is equal to C beta 1 plus beta 2 is nothing but this inside element in where it is in domain, that is V. Okay, it is in V. Okay, so this is belongs to V. Okay, here inside element is belongs to V, this inside element is belongs to V. If it is belongs to V, then it will be in R of T, then it will be in R of T. Clear? T of alpha 1 is equal to beta 1, alpha 1 is belongs to V, then beta 1 is belongs to R of T. So here also it is in belongs to V, then this will be belongs to R of T. If it is in R of T, then R of T is a subspace of W. Why? Because this is the condition for subspace. This is the condition for subspace of linear transformation. Okay. Then RT is a subspace of W. This is V, this is W, means RT is a subspace of W. I hope clear. Then we have here note point. Here I wrote, see, note, if V is a finite dimension, this is V and this is W. If V is a finite dimension, then dimension of RT is called the rank of T. Dimension of RT is called the rank of T. RT, where RT will be? RT will be here. Okay, so T of 1, T of 2, T of 3. Okay, if it is finite, then the dimension of this RT only we call rank of T. Okay, means indirectly, simply, dimension of range space only we call rank of T. So dimension of range space of T is called rank of T, right? I hope all you clear up to here what I explained, two theorems and the two definitions, that much only, right? Now coming to the main theorem, Rank-Nullity Theorem. Okay, the statement of Rank-Nullity Theorem is V and W are two vector spaces over the field F and T be a linear transformation from V to W. If V is a finite dimensional vector space, then rank of T plus nullity of T is equal to dimension of V. This is what the definition of such statement of Rank-Nullity Theorem. అసలు Rank-Nullity Theorem statement ఏంటి? what is the rank nullity theorem statement inside, what it will be once we check. Okay, so this is domain and this is codomain, this is W, here it is V, in middle linear transformation. So we know nullity of T is nothing but mapping elements with 0. Range rank is nothing but another elements of this codomain, right? So dimension of V is nothing but how many elements are present in domain. If we take n elements are present in domain, means dimension of V will become n. N elements are present in domain. 1, 2, 3, 4, 5. For example, 5 elements are present in domain. Okay. In this, 3 elements are mapping with 0. Remaining 2 elements are mapping with linear transformation function. Okay. So then this 3 will become what? Null space of T. Nullity of T. Nullity of T is nothing but what? The dimension of null space. So this is the dimension. So nullity of T will become 3. This is 3 is what? Nullity of T. 3 is nothing but nullity of T. Okay. This 2 will become, these 2 are mapping with this 2, no. This 2 will become rank of T, R of T. R of T is what now? 2. So this 2 plus 3 is what? 5. That 5 elements are here, finite elements. That is the statement of our rank nullity theorem. Means in domain, in codomain, some elements are mapping with nullity of T, some elements are mapping with rank of T, range of T. If you add these two, then you will get definitely the elements in domain. That is the concept of rank nullity theorem. That is the main theme of rank nullity theorem. Okay, let us see the proof of this rank nullity theorem. Since we know null space of T is a subspace of V. ఓకే, మనం ఇంతకు ముందే ప్రూవ్ చేసినాం. ఏమని ప్రూవ్ చేసినాం? నలిటీ ఆఫ్ టీ అనేది, నల్ స్పేస్ అనేది వీకి సబ్స్పేస్ అవుతుంది అని ప్రూవ్ చేసినాం. లెట్ us టేక్ డైమెన్షన్ ఆఫ్ V ఈజ్ ఈక్వల్ టు n ఫైనైట్. వీలో ఎన్ ఎలిమెంట్స్ ఉన్నాయి అనుకుందాం, ఎన్ నంబర్ ఆఫ్ ఎలిమెంట్స్ ఉన్నాయి అనుకుందాం వీలో. సో దెన్ డైమెన్షన్ ఆఫ్ నల్ స్పేస్ ఆఫ్ T ఈజ్ ఆల్సో ఫైనైట్. వై బికాస్ here it is V. Null space is a subspace of V means if it is finite, then null space also will become finite, then this dimension also will become finite. ఓకే, అంటే ఈ నలిటీ ఆఫ్ T అనేది దేనికి మ్యాప్ అయి ఉంటుంది? జీరోకి మాత్రమే మ్యాప్ అయి ఉంటుంది ఎవ్రీ ఎలిమెంట్. సో ఇది ఫైనైట్ సెట్ అవుతే ఇందులో ఫైనైట్ నెంబర్ ఆఫ్ ఎలిమెంట్స్ అనేవి, ఇందులో ఉండే కొన్ని ఎలిమెంట్స్ అనేవి జీరోతో మ్యాప్ అయి ఉంటున్నాయి, అవే నల్ స్పేస్ అవుతున్నాయి. సో ఈ డైమెన్షన్ ఆఫ్ ఈ నల్ స్పేస్ని మనం ఏదైనా ఒక ఎలిమెంట్ అనుకుందాం. దట్ ఈస్ డైమెన్షన్ ఆఫ్ n ఆఫ్ t ఈజ్ ఈక్వల్ టు k. లెట్ us టేక్ డైమెన్షన్ ఆఫ్ n ఆఫ్ t ఈజ్ ఈక్వల్ టు k. సో dimension of n of t is equal to k is nothing but there should be some elements. These elements are mapping with 0. Okay, here it should be some elements. So let us take that some elements are as there exists a basis b is equal to alpha 1, alpha 2, so on alpha k for null space of t. 0 తో మ్యాప్ అయి ఉన్న కొన్ని ఎలిమెంట్స్ డొమైన్లో ఉండాలి కాబట్టి ఆ డొమైన్లో ఉన్న కొన్ని ఎలిమెంట్స్ని alpha 1, alpha 2, so on alpha k అనుకుందాం. ఓకే, సో this means what? t of alpha 1 is equal to 0, t of alpha 2 is equal to 0, like that t of alpha k is equal to 0. Okay, so this is total what? Dimension of V n. Here we have n number of elements, but here we chosen up to k only, but here it should be some more elements that should be mapping with r of t. Okay, so now you need to extend this basis. Okay, you need to extend this to form a basis for V. Okay, V కి బేస్ కావాలి అంటే ఈ కొన్ని ఎలిమెంట్స్ని ఎక్స్టెండ్ చేయాలి. సో లెట్ us take, we can extend B to form a basis for V. Suppose there are vectors after this alpha k plus 1, alpha k plus 2, so on alpha n in V. Okay, V means domain, such that beta 1 is b1 is equal to here b, here b1, just for difference purpose. Okay, up to here alpha k. Now alpha k plus 1 to alpha n is a basis for V. Is a basis for V. We know up to here it is a null space. Okay, nullity of T. Now we have to show this is a range space, base for range space. We have to find rank of this part. If you find, we know rank of that is dimension of n of t we got. Now we have to find dimension of r of t. If you add these two, it should be equal to n. Means now our work is, now our duty is what? Now our duty is to find rank of this. So if you want to find rank of this, you need to show this is linear combination. This should be Li. If it is linearly independent, then we can say dimension of, then we can find dimension of this range space. For that reason, now our work is what? Let us take year to year linear combination, year to year set is, let us take S. Okay, just denotion. Claim is what we have to show. S is equal to T of k alpha 1, alpha k plus 1, so on alpha k plus 2, so on alpha n. T of alpha n is a basis for range space of T. Okay, సో ఇది దీనికి రేంజ్ స్పేస్ ఆఫ్ టీకి బేస్ అవుతుందని ప్రూవ్ చేస్తే మనకు ఆర్టీ వస్తుంది. ఓకే, రేంజ్ స్పేస్ అవుతుందో అవ్వదో మనకు తెలియదు కదా, మనం ఇప్పుడు ప్రూవ్ చేయాలి అది రేంజ్ స్పేస్ అవుతుందో అవ్వదా అని. సో హౌ వీ విల్ షో? ఫర్ దట్ రీజన్ వీ హ్యావ్ టు షో టూ థింగ్స్. వన్ ఈజ్ we have to show this S is linearly independent, then we have to show span of S is equal to range space of T. We will see this span concept in this theorem only. First we will show S is linearly independent. How we will show it is linearly independent? If you take coefficients, some elements in field, then linear combination of these elements with each and every element in S should be is equal to 0. Linear combination should be is equal to 0. If it is equal to 0, if these coefficients are, all the coefficients are 0, then we can say this T of alpha 1, T of alpha 2, T of alpha n is a linearly independent set. That is the concept. What is linearly independent means? For example, A1 C1 plus A2 C2 plus A3 C3 is equal to 0. If this all the coefficients are zeros, then we can say all C1, C2, C3 are linearly independent. This is the concept of linearly independent. We have it in first unit. Okay. So, okay. Now, I am writing here linear combination Ck plus 1 into T of k plus 1. So, means next term Ck plus 2 T of k plus 2, like that, plus Cn T of alpha n is equal to 0. So here T is a linear transformation. No, we know already T is a linear transformation. In question only, in statement only we have it. If it is linear transformation, we can write like this: C of T of Ck plus 1 alpha k plus 1 plus so on Cn alpha n. So T of alpha is equal to 0 means this alpha should be in null space. Okay, T of alpha is equal to 0 means this alpha is mapping to 0. Then this alpha in null space of T. In place of alpha here we have this total part. This part is belongs to null space of T. Okay, already we have elements in null space. What are that elements? C1, C2, Ck belongs to field F, such that, okay, C1, C2, Ck, where this C1, C2, Ck? This all in B set. Okay, here we considered B. Okay, alpha 1, alpha 2, alpha 3, alpha k. It can be written as C1 alpha 1 plus C2 alpha 2 plus C3 alpha 3 plus Ck alpha k. So this is a null space, so that C1, C2, C3, C4, this all are, okay, C1, C2, C3, C4, Ck, this all are belongs to a field F. Then we can write C1 alpha 1 plus C2 alpha 2 plus Ck alpha k is should be equal to linear combination of this part. Why? Because B is a basis for null space of T. Okay, basis for null space of T. So it according by the concept of null space of T, we can write linear combination like this. Okay, so this also belongs to null space of T, means indirectly these two should be equal. Okay, now bring all the terms to this side, then it will be, sorry, this all the terms to this side, then it will be C1 alpha 1 plus C2 alpha 2 plus CK alpha k minus CK plus 1 alpha k plus 1 minus CK Cn alpha n is equal to 0. Okay, so this total linear combination is equal to 0 means this coefficient should be 0 by the definition of linearly independent. Okay, linearly independent definition ఏంటి అంటే if these all linear combinations are is equal to 0, ఇవన్నీ 0కి ఎప్పుడు ఈక్వల్ అవుతాయి అంటే అన్ని కోఎఫిషియన్స్ ఈక్వల్ అయితేనే ఈ టర్మ్ అనేది 0కి ఈక్వల్ అవుతుంది. ఈ టోటల్ ఎక్స్ప్రెషన్ అనేది 0కి ఈక్వల్ అవుతుంది. అంటే ఇది ఎప్పుడు ట్రూ అవుతుంది, ఏ సందర్భంలో ఇది ట్రూ అవుతుంది అంటే ఆల్ కోఎఫిషియన్స్ షుడ్ బి 0. దట్ ఈస్ C1 is equal to 0, C2 is equal to 0, CK is equal to CK plus 1 is equal to so on, Cn is equal to 0. So up to here no need. Okay, now we need to show what CK plus 1, CK plus 2, these all should be 0. If CK plus 1, so on, Cn 0, then T of k plus 1, T of k plus 2, Tk plus 1, alpha k plus 1 are, means this all are zeros, then we can write T alpha k plus 1 so on, T of alpha n is a linearly independent set. Okay, అర్థమవుతుందో లేదో వినండి మరోసారి. ఈ లీనియర్ కాంబినేషన్ అనేది 0కి ఈక్వల్ అయింది అని రాస్తున్నాం కదా. సో ఇది 0 ఎప్పటికి ఈక్వల్ అవుతుంది, ఇది ఎప్పుడు ట్రూ అవుతుంది, ఏ సందర్భంలో ఈ కండిషన్ ట్రూ అవుతుంది అంటే ఈ కోఎఫిషియన్స్ అన్నీ 0కి ఈక్వల్ అయినప్పుడు మాత్రమే ఈ కండిషన్ ట్రూ అవుతుంది. ఓకేనా. సో కోఎఫిషియన్స్ అన్ని 0కి ఈక్వల్ చేస్తున్నాం, మనకి ఇది మొత్తం అవసరం లేదు, ఇక్కడ వరకు మనకు అవసరం లేదు. ఓకేనా, ఓన్లీ ఈ పార్టే మనకు కావాలి. ఈ పార్ట్లో ఉన్న ఎలిమెంట్స్ అన్ని జీరోస్ అవుతే, ఈ కోఎఫిషియన్స్ అన్ని జీరోస్ అవుతే వీటికి కరస్పాండింగ్ మనం తీసుకున్న ట్రాన్స్ఫర్మేషన్స్ అనేవి లీనియర్లీ ఇండిపెండెంట్ అవుతాయి. సో ఇవన్నీ 0కి ఈక్వల్ అవుతున్నాయి కదా. దిస్ ఆల్ షుడ్ బి ఆల్ 0 అకార్డింగ్ టు దిస్ లీనియర్లీ ఇండిపెండెంట్ సెట్. దేర్ ఫోర్ S is equal to T of alpha k plus 1, T of alpha n is a linearly independent set. Okay, up to here linearly independent set concept finished. Now we have to show span of S is equal to range space of T. Okay, span is nothing but linear combination of S. Linear combination of S is equal to range space of T. ఇది range space of T కి ఈక్వల్ అవుతుందని మనం ఇప్పుడు చూపించాలన్నమాట. సో the vectors T of alpha 1, T of alpha 2, so on, T of alpha n certainly span range of T. Okay, certainly span range of T. సో రేంజ్ అంటే ఓన్లీ ఈ పార్టే కాదు, ఇక్కడ ఉన్నవన్నీ రేంజ్ అవుతాయి. అంటే 0కి మ్యాప్ అయిన T of alpha 1, T of alpha 2, T of alpha k కూడా రేంజ్లోనే ఉంటాయి. T of alpha k plus 1 ఇవన్నీ రేంజ్లోనే ఉంటాయి. బట్ ఈ రేంజ్ స్పేస్ వేరు, రేంజ్ వేరు కదా. ఓకే, రేంజ్ వేరు, రేంజ్ స్పేస్ వేరు. ఓకే, సో ఇయర్ range space of T we have to find means we need to find means what are the elements in the range. These are all the elements in range. These are all the elements in range. But up to here we know all are zeros. Why? Because these all are mapping with null space of T. Up to here 0. Remaining all are range basis for range space. Okay, that only I wrote here. See, T of alpha 1 0, T of alpha 2 0, T of alpha k is equal to 0. Thus we get this all finished. This all went means up T of alpha n. This all went means what left then? After T of alpha k, we have T of alpha k plus 1, so on, T of alpha n. Now this remaining part will become span range of T. That is range of T, span of T. Okay. Now S is equal to, this is a basis for range space of T. Okay, now we showed this is the range space of T. Okay, so 1, 2, 3, so on, k plus 1, like this n elements we have in the range space. Okay, up to here this all belongs to null space of T, null space of T. Now how many elements we have here to here? Total we have n elements. In that k elements are which we are subtracting, means n minus k elements are present after k. How many elements we have means n minus k elements we have. This part means in this how many elements we have means n minus k elements we have, right? That n minus k only we call dimension of range space of T, that is rank of T. Okay, so rank of T is what now? N minus k. Since dimension of null space of T is equal to K. We consider in starting only, that is nullity of T is equal to K. Here we got rank of T is equal to n minus K. So if you add these two, then you will get what? Rank of T plus nullity of T is equal to n minus K plus K. Minus K plus K cancel means you will get n. In first line proof first line we consider dimension of V is equal to n. Okay, means nullity of T plus rank of T plus nullity of T will become dimension of V. Rank of T plus nullity of T became dimension of V. Here we got rank of T what? N minus K. Nullity of T is K. And if you cancel these two, you will get n. N is nothing but dimension of V. Okay. This is our required proof. So this is all about rank nullity theorem. I hope all you clear. నా వీడియో కనుక మీకు నచ్చినట్లయితే లైక్ చేయండి, షేర్ చేయండి. అదేవిధంగా ఏదైనా డౌట్ ఉంటే కింద కామెంట్ సెక్షన్లో కామెంట్ చేయండి. మీకు డిస్క్రిప్షన్లో టెలిగ్రామ్ అదేవిధంగా ఇన్స్టాగ్రామ్ లింక్ ఇవ్వడం జరుగుతుంది. ఓకే, మీకు ఏదైనా డౌట్ ఉంటే టెలిగ్రామ్ ఆర్ ఇన్స్టాగ్రామ్లో పోస్ట్ చేసినట్లయితే నాకు పర్సనల్గా మెసేజ్ చేసినట్లయితే, టెలిగ్రామ్లో కూడా పర్సనల్గా మెసేజ్ చేసినట్లయితే నేను మీకు డౌట్స్ని క్లియర్గా క్లారిఫై చేసే ప్రయత్నం చేస్తాను. ఓకే, థ్యాంక్ యూ ఫర్ వాచింగ్. హ్యావ్ ఎ నైస్ డే.